Saxon Algebra 2, Lesson 69. Greetings, students. Today we are going to take those cool gas law problems that we learned about a few lessons back. It was 57 according to John's notes here. So it was a ways back. It was a couple weeks ago. We're going to take that basic concept and what we're going to do is just trick up the numbers a little bit so that we are confused and frustrated. No, just kidding. We're going to use some scientific notation though. So it will be a little kookier, but this is more like what you'll actually see in chemistry classes. So hopefully, or it could also be physics classes. So we'll work with that. See this yellow folder here? This is a reminder to Micah and to me. Micah, you still have open review problems from first semester before Christmas. And leaving this here is our reminder that you need to either complete those or take a 0. And I don't want you to take a 0 on them. So by all means, let's complete them on this week's video check-in, all right? Plan on taking a little extra time because I think you have several. So let's catch up. Okay, let me remind you of our ideal gas law formula. And the idea here is that in the beginning, there's an equilibrium that's struck between pressure, volume, and temperature. And that if you change any one of those, the others will change and balance out. Okay, and we know that these are two-step problems. No, these are not two-step problems. That's something else that I'm thinking of, so never mind. Okay, so what we're going to do is just what we've done before. Well, I should just stop talking and do the problem because I'm confusing myself. No, I'm not. I'm confusing you. Okay, let me read what it says. A quantity of ideal gas had initial pressure, volume, and temperature of values of 40 times 10 to the 4th atmospheres. I'm just putting them in the order. John said pressure, volume, temperature. 0.0003 times 10 to the minus 6 centimeters cubed. Okay, I guess that's a volume measure. I'm not going to listen or worry about it. And the temperature is 700 times 10 to the 4th. Do you see what John's doing to us here? He's creating drama. All right, find the final temperature. So we're going to find T2 if the final pressure is 0. That many atmospheres. This is a 4. Okay, let me just double check because that's so confusing. 3 zeros and a 4 times 10 to the 15th atmosphere. And the final volume was 0.015 times 10 to the minus 14th. Okay, and then John says, begin by solving the equation for T2. And let me tell you what John's thinking is here. His thinking is that if we just fill in all of these wild values in 5 of these spots and then try to solve for this, we're going to have to do quite a bit of algebra and shifting around, right, in order to get T2 by itself and all these crazy yahoos together on one side. I would like to do as little algebra as possible with all of these monsters. Would you agree to that? So what we want to do is we want to start by taking this equation and solving it for T2 as an abstract equation, because then we can just shove all the values in where they belong and simplify. We won't have to do any algebra. We'll do the algebra first with just these letters. It's a great idea. So what I'm going to do is I'm going to start by going P1 times V1 over T1. I'm doing that. And now I want to solve for this. So I'll start by cross multiplying, and I'll get P1 V1 T2 equals, right? I'm putting the ones in front of the twos just as my way of keeping this orderly, right? So I cross multiply, these guys are on one side, these guys are on the other side. And then I want the T2 by itself, so I'm going to divide by P1 V1. Okay, that's gone. Now I've got a nice formula that I can just plug things into in order to solve, all right? So, I guess I'm gonna work down and then go up and use this other column, all right? I'll put a wall in there. Okay, so I'm gonna say that T2 equals, whoops, I forgot the equal sign. T1 is 700 times 10 to the 4th. Oh, this is going to be too crowded. Never mind. I don't like it. Let me do this. I'm going to copy down this formula. We said that T2 equals okay, that's our formula rearranged. I just copied it to this page. The first temperature is 700 times 10 to the 4th. The second pressure is the original volume okay, all over the original pressure. Oh, look, I'm mixing dots and X's. I'm sorry, you guys. I'm making it as crazy as possible. There's the P1 and then V1. And just for good measure, I put in one more dot and one more X. Are you confused? I'm doing everything in my power to confuse you. JK, not really. Okay, just a second. My book needs a thumping. Okay. Now you can see, all right, well, this looks kind of familiar. We've been doing things like this, right? This is an exponent. All right, so what we have to do is we have to get all of these into proper exponential form. And just a second, I think I copied something wrong. P2. What I'm doing, I don't think you can see me very well. Here, I'll move back up. I'm double checking my values. T1, 700 times 10 to the 4th. P2 is 0.0004 times 10 to the 15th, yes. V2 is, there's where my mistake is. I copied it wrong. 0.015 times 10 to the minus 14. Oh yeah, see, I had that one twice. That's another way that you know you've screwed it up, is that you should use each of the values John gave you once and only once. Okay, I think I'm back on track now. Copying error, forgive me. Now what we need to do is we need to fix each one of these so that we have clean exponential notation. Now notice that these guys don't have a lot of decimals. This is the only one. So I'm not going to round anything. I'm going to use exact numbers. That'll be fine. Okay, so this, let's see, 700 needs 2 more jumps. So that's going to be 7 times 10 to the 6th power. And this, let's see, this is going to need 1, 2, 3, 4. And those will be negative jumps. So that's going to be 4 times 10 to the 11th. I'm double checking my answers as I go. Yes. And then this one, I only have to move it 2 more times. That's going to be 1.5 times 10 to the negative 16, right? Because I need to make it even smaller. Yes, that works. This is all good. Now we just need to do the denominator. This needs 1 more jump, so that's going to be 4 times 10 to the 5th. And this, 1, 2, 3, 4. So this is going to be 3 times 10 to the minus 4 more minus 10. 10 to the 5th. Okay, beautiful. I'm just checking my work as I go to make sure I'm not making any mistakes. Okay, now let's take all of the lead numbers and put them together. It's 7 times 4 times 1.5 divided by 4 times 3. Okay, the 4's cancel. And let's see, 1.5 and 3, 1.5 goes into 3 twice, right? So it looks like this is going to be 7 over 2. That is 3.5, right? We'll switch it to decimal form because this is a science calculation and scientists like their decimals. So our lead number is going to be 3.5. Now we have to combine all of the exponents on the tens, right? So we're going to be adding what's in the numerator and subtracting what's in the denominator because that's how you use the power or the product rule. We add, and then the quotient rule, we subtract what's in the bottom. So it's going to be 6 plus 11 plus minus 16 minus 5 and minus 10. Okay, I'm adding in the top 6 plus 11 plus minus 16, subtracting in the bottom minus 5 minus 10. All right, so this is going to become a plus 10. So I'm going to add all my positives first. 6 plus 11 is 17, 27, positive, and then that's minus 21, right? So my final answer is going to be 3.5 times 10 to the 6th. And that's the value of T2, right? So I'm going to write that down. Word problems deserve some sort of word answer. And that's correct. And if we wanted to, we could notice that these were being measured in kelvins, and we could put a K in there. Put a unit on it. That's the right answer. Remember that we want to get this digit down to the ones place only. And sometimes, sometimes this number will get big when we're doing this combination. Sometimes it'll get too big and we have to adjust it one more time at the end so that we have just the ones place in there. This is the right answer though. Okay, whew. It was kind of a workout, especially because I had copying drama, but manageable. Okay, let's do one more and then be done with this lesson. Ready? Example 69.2. A quantity of ideal gas had initial values of this says pounds per inch squared. That looks like pressure to me. 0.007 centimeters cubed. That is volume. And 7,000 K. And that I know, oh, let's see, I want to put the K over here. That is temperature. Now, let me tell you this. You might not be comfortable with these, so you might have to go back and look at that chart in lesson 57 that tells you about what the different units are for each one of these guys. That's where you'll find that chart. Here's how I feel about it. I'm really comfortable. I know kelvins are temperature. And I know that centimeters cubed is a volume. This one I'm not sure of, but it's the only one left, right? I'm not as sure. So I go with that, okay? So now I'm happy. If the final volume was 3 times 10 squared, oh, and look now. This time John tells me that the centimeters cubed is definitely volume, so I know I did that right. And the final temperature, T2, was so again, I know that K must relate to temperature, so I know that's right, okay? So what I'm trying to do is get to the right answer without having to be so desperate as to go back, because we all know nobody ever wants to flip pages in the middle of their homework. That's annoying. It just slows you down. So I'm pretty sure I got my units right, because I just used the clues that John did give me to figure out the ones he didn't. Solve the equation for P2 as the first step. All right, let's write it up here again. Okay, and this time we'll use a slightly different solving method. Okay, I'm gonna write it again here. P1 V1 over T1 equals P2 V2 over T2. Last time we cross multiplied and then divided away the pieces that we didn't want. That is 100% fine. That will always work, and it's a perfectly legitimate way. I just want to show you a different way. This time I think, okay, I want to solve for P2. Here's what's clinging so desperately to it. So I'm going to multiply by the reciprocal. I'm going to multiply by T2 over V2 on both sides. I'm going to sneeze. And Gracie's crying. Excuse me. Okay, this all cancels because there's that and there's that. So now I know that P2 equals P1 V1 T2 over that. Okay, so I reordered this to put all the ones first and then the twos. All right, so now before I fill up this page and have to flip and cause all that drama for myself again, I'm going to start here. Do you guys remember when an individual problem just took up like a tiny little piece of each paper? Oh, those are the days, huh? All right, P2 equals, ready? P1 V1 T2 okay, all over. And this time I'm going to try a little bit of a different simplifying technique. I'm going to do the thing where I leave space in the middle and then I'll work toward the line. And so for my denominator, I want T1 times V2. Okay? All right, so now I'm going to work toward the middle and simplify to proper scientific notation. Okay, this one I've got to bump 1, 2, 3 times in the negative direction. That's going to be 3 times 10 to the 11th. Oh no, I've been making X's. I'm not switching back to dots. All right. Next one. Okay, so I squiggle that out because I've done it. Next one is 1, 2, 3. Yes. And then this one, 1, 2, 3 to the minus. So that's going to be 3 times 10 to the 7 minus 3, 4. Beautiful. Okay, so these are all done. Now I'm going to work up from the bottom. 7,000 is 7 times 10 to the third. And 3 times 10 to the 2 is perfect as it is, right? I don't have to do anything more with him. I can squiggle those out because now they're done. All right, there's all the beauty that I have. And our simplification process is exactly the same. We're going to see what happens when we take all those lead numbers off. 3 times 7 times 3 over 7 times 3. Well, wow. Cancel city, right? Goodbye. So our lead digit will be 3. We don't have to simplify that, right? Everything reduced down so much that we don't have to do any adjusting at the end. And now we'll take care of the exponents. Remember, we add everything in the top and we subtract everything in the bottom. So it's going to be 11 plus minus 3 plus 4 minus 3 minus 2. Okay, 11 plus minus 3 plus 4 minus 3 minus 2. All right, let's add together all the positives. We get 15. We'll put together the negatives. That's 6, 7, 8. And we get 7 as our exponent. So our final answer is 3 times 10 to the 7th. We're finding pressure. That's pounds per inches squared, and that is P2. Double checking the answer. Yay, we got it right. Okay, the good news is we've already done these kinds of problems, and the numbers are pretty cute and simple, the way John works them out. They are scientific notation. That's the hard part. And we're also doing this thing where we're solving for the desired variable, right? We're doing this. I don't remember if we did that last time. I'm not sure that we did. That makes it a lot easier when we have these big cumbersome numbers. And these are going to get a step harder. We're going to do numbers that are hard enough that we need to plug them into calculators to simplify. So there's that to look forward to. But for now, I'm sorry, I can't do anything more to confuse you. That's lesson 69. Thank you. Goodbye.